Question number 21. The domain of G is such that G inverse exists. Explain why x greater than or equal to 1 is suitable domain for Gx. So this Gx is actually the x1 minus x. So the graph will be like this, 0 and 1. So this is the 0 and 1. So the root is 0 and 1. So the maximum point or the axis of symmetry will be the x equal to half. Okay, so for this one, if the x greater than 1, so x greater than 1, so we take this part only. So that means this part we don't want. Okay, so when x equal to x, when x greater than or equal to 1, the Gx is always decreasing. Okay, or it is 1 become 1 to 1 function. So if we limit the domain, so it will become 1 to 1 function. Then only 1 to 1 function have inverse. So this one become 1 to 1, then it have inverse. Question number 22. The function h and k are defined by hx is 8 log x plus 2, kx is 5 plus square root x minus 1. So we need to find the hk10. So k10 will be the 5 plus square root of 10 minus 1. So 5 plus square root 9, then is 5 plus 3, it is 8. So the hk10 will be h of 8. So it will be the log 8 plus 2, then it will become log 10. Log 10 is actually 1. Okay, so the answer is 1. Next, find the k inverse and state its domain and range. Okay, so k inverse. Okay, so we need to find the k inverse. Let ky equal to x, then k inverse of x equal to y. So we have the 5 plus square root y minus 1 equal to x, then square root y minus 1 equal to x minus 5. So y minus 1 equal to x minus 5 square, then y will be the x minus 5 square plus 1. Therefore the k inverse of x will be the x minus 5 square plus 1. Okay, so over here we know that the k of 1 is 5 plus square root 1 minus 1, that is the 5 minus square root 0, then it is 5. Okay, and then the k of 101 is 5 plus square root 101 minus 1 is 5 minus square root 100, will be 5 plus 100 square root 100, then it will be 5 plus 10 is 15. So I know that the range of the k is the k between 5 and 15. Okay, between 5 and 15, not inclusive. So we know, therefore the range for k is actually the domain of the k inverse. So the domain for k inverse, so this question asks us to find the domain of k inverse. So the domain for k inverse will be the x between 5 and 15. Okay, and the question asks us to find the range, domain and range. So this is the domain of the f, so it's also the range of domain of k, also the range of k inverse. So the range for K inverse will be the K inverse between 1 and 101. Okay. 23a, show that this can be write as the form in the form. So we do the computing the square. So this one is the x square plus 6x plus 6 over 2 square minus the 6 over 2 square plus 4. So it will be x plus 3 square, and then this is actually minus 9 plus 4. Okay, that is minus 5 here. X plus 3 square minus 5. Write down the range of f. So the range of f when it is 0, so this one the graph is actually the -3, -5, so it's the minimum point. This is the -3, -5 is the minimum point. Okay, because when the x plus 3 equal to 0, x equal to -3, and this is the axis of symmetry, x equal to -3, and then the minimum point will be -5. Okay, so but this one, the domain is x greater than 0, so x greater than 0, so we take this part only, so the previous part we don't want. So the range for fx, so the f of 0 is actually 0 plus 0 plus 4, which is 4. Okay, okay, so the x-axis is actually, the graph that I draw is actually wrong. It's maybe here, somewhere here. This is 4. Okay, so the graph is look like this. Okay, and then we know that it is 4 is the minimum point, and inclusive or not inclusive. So the range of f, so the range of f will be the f greater than or equal to 4. Okay, so the range is greater than or equal to 4. And next, the question asks us to find the f inverse and state its domain. Okay, so to find the f inverse, we need to write the same sentence, that is the let before that I copy this one. No, this is the fx, and then the fx here, and the fx I can rewrite as this after we do the computing the square. Okay, so what we need to do to find the f inverse is let fy equal to x, then f inverse of x equal to y. Okay, so fy will be the y plus 3 square minus 5 equal to x, y plus 3 square equal to x plus 5, and then the y plus 3 will be the plus minus of square root x plus 5, but we take the positive part only, because this one we take the positive part, that's why we take positive part here also. So the y plus 3 is greater than 0, so the y will be the -3 plus square root x plus 5. So the f inverse of x will be the -3 plus square root of x plus 5. Okay, so this will be the answer. And then the domain, so we must know that the domain of f inverse will be the same as the range of the f. So the domain of f inverse will be the x greater than or equal to 4. So this will be the domain. Okay, done. Question number 24. We have the h2gx equal to 37. So the h2g is the h2 of ex, so it's the h of phi ex plus 2, then the phi ex plus 2 plus 2, so we have the 25 ex plus 10 plus 2. Okay, so this is the ex. Okay, so we have the exponent x, then this is actually 25 ex plus 12. Okay, so this is actually h2 ex is the ex. So this one h2 gx, the gx is ex. So we have the h2 gx equal to 37. So the 25 ex plus 12, 25 ex plus 12 equal to 37. 25 ex equal to 25. Exponent x equal to 1. X equal to ln 1, and ln 1 is equal to 0. Okay, if you're not sure ln 1 is 0, you can use the calculator to calculate. Ln 1 is equal to 0. Okay, done. Question number 25. On the axis below, sketch the graph of the x squared minus 4x minus 12. Show the coordinate of the point where the graph meets the axis. So we have the x squared minus 4x minus 12 equal to 0. Then we will have this one equal to 0. Then we have the x 2 6 16 minus 4 plus 2, x equal to negative 2, and x equal to 6. And then the x equal to 0, then the y will be the modulus 0 minus 12, then it is 12. Okay, so we have the 12 here, and then we have the negative 2 and the 6 here. Okay, so negative 2 2 4 6 6 somewhere here. So we will have this one, and then this, and this is 12, and this is 6. Okay, so find the coordinate of the stationary curve. So we know that the axis of symmetry is the x equal to negative 2 plus 6 over 2, then it is 2. So when x equal to 2, y is modulus of 2 squared minus 4, 2 minus 12, then is 4 minus 8, then is modulus of minus 16, that is 16. So we have the 2 16. Okay, so it's 2 16. So this one, the maximum point here, this one, the graph that I draw is slightly wrong. Okay, so we will have something like this. So we have the 2 16 here. And then next, find the value of k such that this have only two solution. So only two solution, k, so when k equal to 0, it will have two solution. Okay, and then if this one we go up again and go up again, so this part 3 solution, this part 3 solution, and then this part have 4 solution, and the greater than 12 there we will have greater than 16 there we have 2 solution. So this one 2 solution, This one also 2 solution. So the value of k is equal to 0 and the k is greater than 16. Okay,